Good afternoon, good morning, and good evening, wherever you are. Welcome to ICorr Aberdeen branch webinar in February 2023. Thank you very much for joining today. We would be hosting today's event only on webinar session today, and I'll go through quickly through our ICorr introduction for ICorr Aberdeen branch, and then hopefully I would let our speaker talk about very interesting topic today. So I'll just go through quickly. The introduction we usually have is just related to very quick thanks to our committee, which has actually been there for quite few of them are been very active in last very few years. Let me see if you can see the screen. Yes, of course you can. So in fact, thanks to all of our committee members. If you are, cheers, thank you very much. If you're interested in joining us, please, we are looking for 2 to 3 members for Aberdeen branch, if potentially possible from Aberdeen, but we're open to any of the considerations. If you please are interested, please give us a shout. The next bit is thanks to our sponsors. We have got quite a few company sponsors, about 17 of them, who has chosen us as a company sponsors, and the other ones that you have got logos here are the ones who are our branch sponsors. And thanks to all of you members, about 252 of you have accepted or elected Aberdeen branch to be affiliate branch member. And if you are interested in receiving 2 emails per month, we request you to send us an email on icorrabz@gmail.com, and you would receive any of the activity we have in Aberdeen, and coming to any of the webinars like this one. We will welcome you to join us on the mailing list there. The next bit is the 2022-2023 branch program. We have got very extensive program for this year, and we have got quite few events, almost 1 per month. And today we are having this event, Enterprise Digital Solution for Asset Integrity Management, by Raza Amin here. We had a very good program done on the Young Engineer program for 2022, which was a very, very successful event. And we have got 5 of the winners who are going to NACE annual conference, hopefully soon. Coming up, quite few interesting topics. We have got 1 full week of CUI related presentations. We have got industrial visit. We have got quite a few good topics coming up, hopefully soon. So with that, I would like to introduce our speaker for today, and is Raza Amin, who is a Managing Director and Integrity Director of NCA Consulting, based in Malaysia, also in Middle East. So he has got 29 years of experience in engineering, technical consultancy, and advisory training and management. He has been responsible for leading safety and process engineering project for the offshore oil and gas platforms and mobile offshore drilling units, onshore gas processing plants, chemical plants, and refineries. He has extensive work experience on the oil and gas facilities throughout Europe, Middle East, Africa, the Far East, and subcontinent. Raza has been managing consultancy projects for various disciplines, such as risk-based inspection, assessments, life extension studies, reliability-centered maintenance, instrument safety, integrity, safety integrity level, engineering critical assessments, and also oversee the implementation of Alpha-Phi, a modern and comprehensive cloud-based database application module for the entire asset integrity management system for petrochemical industries. With that, I would request you all to put your hands together, of course, virtually hands together, to welcome Reza for the presentation. And before we go into the presentation, I would quickly, while we are switching the screen, I would request you all to basically put your questions in the chat box here at the bottom of your screen. That would be great, so that at the end we will actually go through the questions and ask our presenters to take the questions. I think we can, yes, Reza, we can see the presentation. So today we have got a presentation by Reza, and he would be having a co-host, Matthews, who's going to be hopefully taking the questions from us. Cheers. Thank you very much, everyone. And with that, I'll give control over to you, Reza.
Ijaz, thank you very much. I hope you can all hear me.
Yes.
Perfect. And for what it's worth, you can see me too. So thank you very much for the introduction, and welcome everybody to the webinar on enterprise digital solution. Let me just today's presentation, really, what I'd like to discuss is the enterprise digital system, why we need it. And we all know that asset integrity is becoming a very important exercise and an important role within the oil and gas industry, upstream, midstream, and downstream, largely because we are going through a phase where a lot of the assets are aging, and integrity is identified even by the UK HSE as one of the key contributors to a major accident hazard. So that's the first step. So managing asset integrity is critical. Why digital enterprise system? Is because managing asset integrity, is multifaceted, is multi-components. You've got all the different components of an operating asset, and the components literally run into hundreds of thousands, and to be able to assess, analyze, and then make key risk decisions is important. To be able to do that, you need a smart system. Otherwise, you are not, generally you're unable to get the efficiency that you require in integrity management. So that is the backdrop of this presentation, and hopefully I can. Hopefully you can see my next screen. A quick introduction. I have already kind of given you the backdrop of this. First, I'm going to go through why we need a digital system. What are the key challenges or the problems that the industry is facing in managing integrity, which the digital solution can address? What makes an enterprise system? This is not a software. This is an enterprise system and a solution. And I will explain to you what makes an enterprise system and that one should have for an asset, and the agility that you require in today's environment. We have a very dynamic oil and gas industry. It's forever evolving. We have got multiple assets, different types, and for that you need we have operating companies with different procedures and processes. So if you are not having an agility in the enterprise system, it's there can't be one that fits all, unfortunately. So agility is important to have within the enterprise system, so that you're able to implement it across all asset types and operating processes and management philosophies. Okay, and I'll wrap it up with a recap. So let's go straight into why is an enterprise digital system for asset integrity management required? Well, first of all, over the years, there's been silos created for managing asset integrity, and they are created for two key reasons that I can think of. One is that we've got companies who have evolved over time, and they've started off with a small part of the process. Let's say, let's tackle static equipment and static integrity management, mechanical integrity management for static equipment. Then they've kept on adding things to it, and it's evolved, and it's created those silos. And the second reason is that basically you've got large amounts of data that you've got, and you've not really had a clear strategy around putting all of these things together. So the silos have been created. The other reason is the organization itself. If it's a large organization, if you've got different department wants to control their own discipline, and that's created silos as well. However, the disadvantage of that is that decision making it gets very difficult. Risk management for particular discipline can be managed, but the overall risk for the whole asset gets a little tricky. So visualization of the overall health of the asset through the silo systems that you've got doesn't work. The data flow from, for example, risk-based inspection into anomalies into fitness for service, these things you're unable to achieve. So you need to standardize the process, and that can be done through a digital platform. You can centralize all the data and integrity solution through a centralized platform, and therefore you must avoid as much as you can creation of these silos, and if not, reduce it as far as possible if you want to derive efficiency in the integrity process. Okay. Second one is you've got to create you want to be able to pull together all of the information that you are getting from your operation and your systems or operating systems into the integrity system. And they are all useful information to make some key decisions. So if you are unable to integrate them, and there is a lack of integration, then it is very difficult for you to get all live acquisition of data and then processing and assessing of those data. A good example would be if you've done an FFS, and if the FFS assessments have told you that you've got to derate your system, well, your operating envelope has reduced now, and you need to track that through your production PI hexaquantum system, whatever you have, get those data, laboratory information management system data, and then put it through the what they call an integrity operating window limits. If you don't have a system in place, it's very hard to track the exceedance of that. So again, you need to be able to integrate your asset integrity system with this. Now, it also generates a lot of recommendations, and they need to be pushed through a CMMS system. If you have to do all of this work manually, it is prone to you delaying the whole entire process and then falling behind on integrity, not actually achieving the integrity results you're looking for. Okay. The next one is really, if you've got no workflow, you really have poor accountability, and you need a standardized workflow system. If you don't have it, you don't really have accountability. You don't have an audit trail. You may have bottlenecks, and you've got overdues in your PM and CM, but you don't really know where those bottlenecks are. Where are those constraints? If you have a centralized system with an common integrated flow across all disciplines, you can manage it where you've got reporting, you've got assessment, you've got checking, you've got implementation. That workflow and accountability within the organization for each part of this can be managed effectively. So it is, again, important to have a common integrated workflow process with clear accountability integrated into the system, so the system can speak to each one. And the system can give out notifications to those people who are lagging behind in their corrective actions. So system is now enterprise. The enterprise feature is that system now is communicating back to the team, not just that the team is utilizing the system. It's not a one-way process, it's an interactive process, and that's how the enterprise system operates. The next one is duplication of information. And as you know, you've got any asset has in different components, and they are very distinct in their feature. Structures are very different to pipelines. Pipelines are very different to static equipment. And you've got different contractors, different teams working on this. The reporting of all of these findings that you have can also be very inconsistent depending on who you have. If you've got a shutdown turnaround campaigns, you will have multiple contractors working at any one time. So how do you streamline this if you've got this inconsistency in reporting, first of all, and if it's not digitized processing, it's very difficult to then quickly bring it in for assessment within the integrity process. And if you're not doing that quick enough, then you're going to have delays in your corrective actions, and that can lead to integrity risks. So again, to avoid these duplications, to streamline the reporting, to be able to have a structured data coming through the system that can be easily used for analysis and assessments, it can be achieved with a common and a centralized platform system. And the enterprise system also is designed to validate the information that's coming in. For example, you've done one inspection, the next inspection, actually wall thickness has grown rather than reduced. And those inconsistencies can be picked up by the system also. So it's a smart system, and that's how it should be, so that you get true data that can be used for integrity assessment. We also have data security issues. You have scattered data storages, and you're unable to use, the users are unable to use this and share them at the right time. And again, with a common platform and a storage, you can achieve that. To maintain security of the data is of paramount importance, and the system can actually, you can build the security levels that based on a company policy that allows access to a certain point to certain groups of people. That way you are maintaining security of your data as well. So and the last one is around the transparency. You want to be able to collate all the reports, and you want to make good decisions. Well, if you haven't got the analytics, if you haven't got the visualization of the analytics that you've done, you've not, it is extremely difficult for you to get the really visualize the health of the asset or a component of each of those assets. So again, the system allows you to do that because it has all of the analytics module very specifically designed for each of the components, static, and I'll explain those to you in a minute. So these are some of the challenges that you're seeing, and this is why a digital system, enterprise system, is critical in managing asset integrity. So what is an enterprise system? It is not, as I said earlier, it's not a software, it is an enterprise system. What makes it enterprise? There are 5 pillars. Number one, you must be able to assess register every single component of the assets, and there are different categories of an asset, from static equipment to pipelines to offshore structures, onshore structures, rotating equipment, instrumentation, electrical, wells, whatever you will have on an asset. You must be able to create the adequate register with technical information for each of those components, and then to be able to analyze each one and their integrity of it. So you must be able to do that. Second is, as I said, integration is extremely important with CMMS system for auto-generating orders, and then updating the integrity system with what work has been done, so that your next scheduling takes into account what's been done. Your laboratory information system for any composition changes that you have, that can increase your degradation within the system. It can accelerate your deteriorations within the system. Your production system for managing duration, if you like, and make sure that you're operating within certain conditions, IOW conditions, and so on. And nowadays, a lot of companies are going for live sensors, PermaSense, for example, and you're getting live corrosion rates, and you can do corrosion analytics with it. This is done on a polling period of whatever you set it at, every 2 hours, every 6 hours. This much data is you are unable to process without a proper digital system. The third part is organizational behavior. You should be able to map the entire organization that manages integrity, and typical disciplines are integrity engineers to inspection teams, the RCM guys, RBI engineers, and so on. Everybody has a role to play. The system can communicate back for their input at the right time. So, for example, if an anomaly has been detected, then the assessment of the anomaly should go to a certain person, and then system communicates that. So organizational behavior has to be built in. Fourthly, you've got the system should know exactly what you're trying to achieve with your integrity goals, and they are largely driven by legislative requirement, corporate requirements. You've set your KPIs and so on. So you need to build those into the system so that you can track against your goals that you've got for the system, for the integrity goals that you've got. And last but not least, you've got the IT governance, and you want to centralize all your data and make sure your data is protected. These 5 elements are important to have an enterprise system. Here is a framework of asset integrity management. The diagonal modules that you are seeing here in a digital system, you start with asset management, where you store in data at component level. You can synchronize it with your CMMS system, download it for quick implementation. You can download all your, if you go prescriptive schedules, that you can download those and then create your PMCM module. But you want to move away from prescriptive, risk-based, and all the modules that you see here, these are all the analytic modules, and all the RBI results are then used to go from prescriptive way of doing PMCM to risk-based approach. And you can create all your work packs once the inspection schedules are done. You want to create your work packs. This is a very lengthy exercise, and it needs to be meticulous in ordering, providing the sequential ordering numbers, as well as getting the right methodologies used for each of the inspection type. API defines that. You should have a library within the system that actually you can pull through and auto-generate all of the work pack. If you do that, you can get very consistent approach. Even written scheme of examination you can build into this. You can get a consistent approach, as well as very accurate information about what methodologies to use and what precautions you need to take during your PM and CM. And with once information is put in, this entire work pack generation process is automated, and that can be given to the team to perform the activities. After that, if you find any defect, that is managed through the anomaly process. Now, I have found that there are many companies pay a lot of attention to RBI, but what I call the back end of the integrity management, little focus is the anomaly management itself. And when that happens, what you do all the work in terms of performing your RBIs, doing your inspection work, generating all the reports, but you're not really seeing the integrity improvement. And that's because of a very poor anomaly process. Now, if anomaly is obviously of a significant nature, then it needs to run through a level 1 or a level 2 assessment using API 579 guidelines. And that is, you have an FFS module that allows you to do level 1 and level 2 assessments. For static equipment, if you're doing any monitoring, we monitor all the data, all the inspection results, wall thicknesses, all the UT work that you're doing. It gets into monitored data, and you are building a profile and a trend over the years, and you're seeing how progressive any of the defects are, and you're calculating remaining life, performing REM life assessments. And if the REM life assessments are is telling you that the REM life is actually shorter than the RBI predicted, then this should automatically override the RBI results. And you should do more monitoring than what the RBI is suggesting. So there is a refinement process happening here. And as I said, if the defects are significant, and if FFS has told you that you need to derate the system, you need to be managing your integrity operating window. You set your new operating conditions for your asset and manage it. And here you're putting data with the interface. These red boxes are the enterprise systems. Here you've got the PI or exaquantum system where you're getting the production data, and the LIMS system. You are getting a live feed on any exceedance that you might get on the IOW. Again, if you want to automate the entire inspection process, you can use your data logger systems, which are explosion proofs, and then you can configure them to get consistent reporting, and that reporting can be pulled straight into the work pack management and the rest of the anomaly, rest of the asset integrity process. So here is a basic framework. Now, it's not the same for every company. Here is an example of a company who wanted to do it, have their own requirement. This is why you need the agility, because not every operator is the same. This client, although I'm showing you 8 integrations, the red boxes are integrations. This is a PrimaSense, this is the live sensors. They wanted to build the corrosion prediction algorithms to optimize their corrosion prediction between correlations and the actual data. So they've built that, and they've also built integrity assessment with a particular focus on specialist component like mixing point, corrosion and insulation, dead legs. This is where you're most likely to get corrosion and damage mechanisms. So here is an example of a client or a company or an operation that wanted to do it differently. They also want flange management and SRVs. So here is a slight difference, and you should be able to have the agility in the system to be able to architect exactly per operations need. This is where I go into the agility now. So if you need the agility, how do you achieve the agility? And that is very much in the technology that is available. You go back 5 years, literally, every single system, digital system, was hard-coded into a software. Software engineers, the integrity engineers sat down with the software engineers and they hard-coded everything. However, that does not provide agility. And every time you wanted to change a digital system, you had to go into the hard code. People moved around, changed, you lost that knowledge, and it became a very, very extensive exercise and a very costly exercise and a time-consuming exercise, prone to errors. So what has happened now, industry has moved on, and there is enough digital technologies available, and you can build every single industry, whether it's oil and gas or fintech, they've developed these technology platforms. And what are they? These platforms allow you to build any software without coding. So once you have this technology platform, you can literally configure API 581, RBI, a fully quantitative model, just without doing a single code of programming. You can simply configure it. It's almost like writing an essay, and it can be done by engineers and not by software. So once you have this technology, you do not need software engineers anymore to build any software. Okay, and it is easy to configure. Zero code, as I said, is no code. It can be a cloud-based system. You can centralize all the data. You can use it across multiple assets, multiple geography, and there are huge advantages in doing that. So that's the technology that is going to give you the agility. Client comes and says, my anomaly process is a bit different. My the processes that I'm using for various parts of integrity management are different. The reportings are different. People who manage things are different. So how do you configure quickly these changes and make it available? And the solution that is out there today is to build it through this technology platform. The technology platform has all the enterprise features you can build into your system, and you can provide connectivity between each of the modules. So you can pass data from your asset integrity management module into your CM and PM planning. RBI can connect and pass on data from RBI on the scheduling, and so on. So this connectivity is provided in an enterprise system. So you don't have to create silos, and you have to physically put data from one module to the other. And that is actually extremely time consuming and almost provides a huge hindrance in managing the process more efficiently. And of course, the system can give email notification, on-screen notification for each engineer who's involved in the process. It'll create his do list, and it will maintain, it will have the time audit trails as to when it was given. You can have a workflow system for report, assess, check, implement, approve, and implement process. Collaboration, you can invite people for as a collaboration technology within it. Caching technology is crucial because in our industry, you look at API 579, 1,250 pages of equations needs to be processed and multiple times. You need the iteration power, and that is done through a caching technology. And of course, you want to be able to navigate through your visualization, and can be done through your text search and advanced text search. So I'll talk a little bit more about that. And here we talk about the visualization that I just told you about. You can create all dashboards for every single risk category and every single component, and these can be all of these screens can be dynamic, which means that you can drill down from this for troubleshooting exactly what the issues are. So these are great visualization, and this is what gives you the visualization of the health of the asset, and you can have it at a component level, to an equipment level, to a system level, to a deck level, to a platform level, to a field level. You can have a visualization at every level, and that is suited to different management groups within an organization. You can do your visualization of your integrity data on a 3D or a 2D schematics. The lollipops that you're seeing at the bottom, these are all the inspection points. You can click on them, and you can get your risk levels for each of the test points, so overdues, remaining lives, what are the anomalies that you've got, and you can drill down and you get all the data. So visualization is key. If you don't understand exactly where the issues are, it's hard to manage the integrity, it's hard to focus where they are. And how do you prioritize these risk levels? Well, we need to understand exactly how high the risks are, and the visualization tells you where it is. So you can spend your resources where the high risk components are. The system can also do your 3D visualization. Now everybody's going into this digital twin arrangements, where you want to be able to walk through your system, see the assets in a digital twin, and be able to understand where all the risks are. So you can see that these platforms are in different colors, and the color coding is based on the risk levels that it's seeing. And you can visualize them, and you can click on any of these members that you are seeing, or any part of the platform, and the integrity data will appear on the right hand side. And you can drill down from there to the actual base issue that is driving the risk levels for those components. Here is a visualization for barrier management. This is a key tool for process safety management. Process safety and integrity are very coupled, and safety critical elements are extremely important, as we know through the safety cases and formal safety assessments, that they're extremely critical for managing major accident hazards. A lot of the soft barriers that come from actually integrity management, and they need to be visualized, whether you have got healthy barriers or compromised barriers or failed barriers. And if you know them, then you are able to see the risk, the major top events that you've identified within your safety case. How do you visualize or operationalize a safety case? Well, this is a fantastic way of looking at live data of your assets in a bow tie arrangement. Okay. The AIM system, like I said, should be able to integrate with any of the operations digital systems that's there, so that you can get live data coming into the AIM system for giving you more accurate information, and to be able to do your assessments based on the live data. As well as that, any decisions that the AIM system makes, you want to be able to implement it through your CMMS. So that information needs to be processed and sent to the CMMS system, like Maximo or SAP or whatever the operations is using, or Oracle data suite. So you should be able to do that, and that automation actually reduces the overdues and streamlines the entire process for integrity, and you are kept up to date. And therefore, any visualization you're getting of the health of the asset is a true reflection of where the asset is. Okay. So there are a number of parts of integration. So CMMS, you can synchronize it, the AIM system with the CMMS system, like your Maximo or SAP. You can download your PMCM, which I already mentioned. You can update both ways into AIM system as well as on the CMMS side. You can, all the corrective maintenance that requires you to generate work orders can be automatically created with an instruction from asset integrity system, and then the notifications can be received into AIM system to update the RBI models. So these integrations are important. The other one is the production system, as I said, Pi and Hexaquantum system for managing the IOWs. You've got the LIMS system. Again, you've got changes in your compositions which are detrimental to the asset. Then you want to be able to track those, and of course the UT data loggers I've already mentioned to you. So you can do multiple integrations, and you should be able to do that if you want to have an effective digital system. Implementation is key. All the companies have kept data on their Excel sheets. They are often not consistent. And how do you pull this data into this so that you don't lose the history? You must have a very smart import-export facility that allows you to do that. And when you pull the data in, it should be able to validate the data and make sure that they're correct data. A smart, what you call a data migration system, should be available in any enterprise system. You've got the digital platform where you want to maintain all your documentation, integrity documentation. So if you've used document P&IDs, your ISOs, any mechanical drawings, you've taken some pictures to show the exact findings, then they need to be at a certain point within the integrity process. And then if the process is improved, you can add on what work has been done and what the latest findings are. And that needs to be kept. So you need a system that is easy to use. You can drag and drop this information. You can have the high resolution data collated, so there is no ambiguity about what information was used and what the results have been achieved. If you're doing risk assessments, you want to know exactly which corrosion loops you've used, which P&IDs you've used, which versions. It's all in one place. And you must have a technology that allows you to not clog up your system, but gives access to the information at the right point. This is my pretty much coming to the end now, and you must have all the analytics built into an enterprise AIM system. RBI, static equipment, API 581 has a fully quantitative methodology. You can use that. Some operators are still using qualitative approaches, whatever their methods are, but as long as they have a robust system in place and they have a consistent approach. So you must have those, this modules should be able to allow you to do this assessments. RBIs for onshore pipelines, RBI for onshore structures. Offshore, you've got the pipelines, offshore structures, rigid risers, flexible, particularly around FPSOs. They use flexible risers, they use mid-water arches, plats in some cases. You need a methodology that allows you to assess this. For RBI for hull and mooring, RCM for all your rotating machinery, SIL for all your shutdown system based on IEC 61511 for the offshore industry. You should be able to achieve that. We have shutdown system. It's a critical safety critical element. However, and we go through great lengths in classifying it and verifying it during the project phase. However, in the operating life, we don't know whether that SIL level is still valid or not. You need to be able to track this. And of course, the FFS API 579 allows you to, methodology allows you to do level 1 and level 2 assessment. Very rarely, when you do have a very critical issue, you might need to go to level 3, but you need analytics tools which are very specific to the damage mechanisms. So that they're not generally done outside, and then the data is used in the FFS modules to do your assessment. So the consequence modeling and so on is done outside the FFS module for level 3, but you can do the assessments. And then you got the IOW, as I mentioned earlier on, based on API 584. And then we've got the methodologies for analytics for each of the specialist component. These are very important because although they are small within the scale of the asset, but often the bad actors, because dead legs, we've got static fluids in there, and they're prone to accelerated damage mechanisms because of that. So you need to have a clear focus on that, and you must have analytics for all of this. And then you have a comprehensive digital enterprise system that will help you manage the integrity of the entire asset, may it be offshore, or any of the onshore asset, petrochem, chem, as well, gas processing, refining, whatever they may be. And they are equipment heavy. Without a digital system, it gets very, very difficult. So my last message as a recap is that an enterprise system will give you the modular connectivity and features that is going to make it a lot more efficient in transferring data from one module to the other and performing assessments. A zero-code platform is extremely important for agility in developing an architect that is suited for a given organization and an operation. It covers the entire AIMS framework, starting from asset management all the way to anomaly and management and recommendation. That's the entire framework. It should be able to integrate it with other data systems and live to give you the fast and live updates for giving you the visualization that you need of the health of the asset. Fast migration from the legacy system, whatever they may be, structured or unstructured data is important. Otherwise, it could be cost prohibitive or time prohibitive to migrate into a more sophisticated system that can achieve good efficiency and therefore good risk management. And then the modular system can also allows you to phase your entire AIMS strategy. So if you don't want to go into a full scale asset integrity digital system, but you want to implement the framework with certain critical where the major issues are, you want to focus on that to start with and then progressively build it, then modular architect allows you to do that. And last but not least, the whole purpose of it is, if you have the visualization, if you compare the results of integrity with KPIs that you've set, the integrity strategies and goals that you've set, the regulatory requirements that you've set, if you can not measure that, then you don't really know exactly where you are and how far you are away from a major accident hazard. And major accident hazard, as per KP4, I believe, key program 4 from HSE, was the key driver. And in today's environment, so many assets have gone past design life that you can't do the asset life extension if you haven't been practicing a good asset management process, because you just simply don't have the data to do the asset life extension work. So having a good system in place and having all the data in place allows you to even extend the life of your asset if you choose to do that. And all operators desire and opt to extend life. And we've done a number of life extension work. We find that if the asset integrity process is poor, then it's extremely hard to actually conclude how much remaining life you've got in different components of the asset. So digital system, an enterprise digital system will allow you to achieve all of those goals, integrity goals, management of major accident hazards, as well as achieving a life extension at end of asset life. So that's from me. I hope you found it useful. We still have a little bit of time for any questions that you may have. Thank you very much.
Cheers. Thank you very much, Reza. Sorry, who have joined us lately. I'll just introduce myself again. I'm Mohammed Ijaz. I'm currently chairing Institute of Corrosion Aberdeen branch, and I would request you all to use the chat box to ask the questions, please. I've got already quite a few very, very interesting questions, and I would probably go through them one by one. We have got Matthews, Warke, and Reza Amin available to answer the questions. The first one from Stephen Tate, who is, by the way, our Institute of Corrosion chair as well, here in Aberdeen as well. He said that, thank you very much, Reza, very thought-provoking presentation. The question is, I wonder about the disciplines using single system, as this has been historically very difficult to achieve within energy operators. Sometimes operators outsource an entire discipline, for example, structures, with the vendor using its own system. Would you like to comment on that?
Yeah. That is one practice some of the operators have. They outsource the entire asset integrity process, and largely that depends on, and in our experience, that depends very much on how big the operators are. Big operators tend to keep that. They want to own the system and they want to manage the system. Smaller operators tend to outsource the entire asset integrity function. However, they want to maintain it in one system. So they have that all connectivity and they have more efficiency through the system. So that's my experience. And I hope I've answered your question. If I haven't, then I'm happy to add to that.
Raza, I will add there. We know that what we are trying to do here is to try and remove the data silos. And this is the practice which has been happening from years, where we are creating data silos from various reasons. And when the companies change contract, they lose information across different equipment types. For example, structural done by a vendor, and when they change contract, they lose it. So what we suggest is the operators to have one system which every vendor is using it, and then you safeguard your data for many years with that. Sorry, you're mute, I think.
Sorry. In fact, my system decided to bail on me within a second. Yeah, sorry, I'll just go with the next question. The next question is from Calvin Nagala. He's saying that I might be missing something, but I don't see how one software or database can handle so much real-time data and at the same time work effectively. What would happen if the system was to be compromised? Do you shut down the asset while it gets rectified? Also, the time to pinpoint the problem, etc.
Okay, so the kind of digital platform we are talking about is it can be hosted from a cloud, and cloud normally has a snapshot of every minute, every 5 minutes, every 10 minutes for the whole day, and for a week, and for months. So if there is anything happens, then we are able to go back to the previous version of it. Normally this system, because it's a digital platform and it's fully configurable, normally if there is anything, it will be immediately known. And it can be rectified from the root quickly. So I think you don't have to really, normally it is never seen that it will shut down fully, but if it happens, the support system should work. Level 1, level 2, level 3 support manages that kind of thing for the digital platform. I hope that answers that.
Yes, to me, of course, it does. The next question is from Mohsen Al Hadid from Qatar, apparently. And just to basically acknowledge, we are receiving so many very good questions from all over the world. And thanks to all of those attendees who are actually attending this event, even from very, very far east. Apparently, some of them are, there is about 2 o'clock in the morning there. So I highly appreciate the contribution and the questions there. The next question is from Mohsen. He's asking that one of the great challenges in applying digitalized solution across the organization is specific license of different softwares and challenges attributed to smooth interface of these softwares. what would be the best approach to integrate different modules across different businesses unit?
Yeah, I think this is what we are trying to highlight in the initial part of it, duplication of information, the data, the efforts done by people, the processes. We should try to reduce it by having a digital platform which takes care of different thing and put it into one integrated place. But yes, it's possible that you have come up with some model for with several years and you don't want to give away that one. Then we can use the digital platforms integration gateway to connect to those systems and bring the data use back to the platform, where then you can do the key decision making, all the trending and graphs and with that. Okay, but our whole idea is to have a digital system which is an enterprise level and try to avoid the data silos from there.
Great. Adesiji Enjuran, who is our vice chair from Institute of ICorr Aberdeen branch, he's asking, how would the enterprise system handle deviation or specific inspection requirements if process uses standardized inspection scopes as defined in the enterprise system library, as you have already indicated, was stipulated by the API? That makes sense.
Correct. Yeah, so this is again touching as per what we are thinking in the digital platform. It's a no-code system and allowing you to quickly configuring it into the system if there is any non-standard things you want to do. There are different equipment types, different inspection types, inspection methods, and the scope, the kind of checklist you put into the system varies across different type of inspection and different equipment types. So that can be configured into the platform. User by themselves can go in and define for what kind of inspection, what checklist to be used, and by that this deviations can be managed. But on the same time, there are clients who wants a platform which is ready to use. So in that case, we can use this standardized APIs. But when you want to have deviations, you have a different processes. You use the platform to improve it further for your needs.
Cheers. Thank you very much. The next question is from Mohsin again. He's asking that can data be integrated for downhole upstream with topside downstream facilities?
Yes, of course. So if you look at it earlier, the process flow which was shown, everything is interrelated and transferring data from each other seamlessly. So this is the beauty about the system. It talks to each other and transfers data. So if you have a upstream related information, a pipeline coming from upstream going into a downstream, we have cases, clients who are managing gas transportation pipelines and stations coming from offshore to the onshore. The system manages entire assets for that. Offshore asset is managed using the offshore approaches, and the downstream assets are managed in the downstream.
And the same would apply from wells onto the top sides, if you like, which was the reference made.
Yeah, that's great. Just to answer quickly, of course, so Yandele asked that if the soft copy of the lecture material will be available, we would hopefully make that available with the liaison with the host on the ICorr website. And of course, this meeting is recorded, so this would be available at a later stage. The next question is from Adesiji, is that what is your view on the use of API 580 and API 581, where API 581 is actually the technology which is focused on quantitative approach. API 580 allows you both. So which one is more favored approach for AIM enterprise system there?
Okay, so many parts of the world right now still looking at qualitative way of doing it because their assets are quite old and they do not have enough information. So they may come up with a qualitative approach with guidelines for 580. But now that 581 is a very quantitative approach, newer assets are all going into quantitative. Those assets which are having the enough information to run the quantitative model, they are using the API 581 quantitative model. 581 itself has gone through a journey from year 2000, having the qualitative, semi-quantitative and a quantitative model, then coming into a quantitative model in 2008, and now 2016 and 2020 addendum, having the quantitative model for API 581. So in my view, when you have less time to do things, you can do qualitative, less critical ones. When you have more critical assets, you can follow a quantitative approach.
Great. We have got 3 consecutive questions by Steve Patterson. The first one is that I may have missed it, but how do you manage barriers to corrosion? All I can see is the inspection, and as we know, inspection, you can't manage corrosion by inspection alone. So the question is, how do you manage the barriers to corrosion?
So our corrosion management models can help on this. There are various different thinning methods. We do calculate the corrosion rates by different methods. We also monitor the chemical injection part of it, the effectiveness of that. So those things can help on that. From inspection, the data which is coming, we do calculate the corrosion rates, long-term, short-term corrosion rates, and coming up with the remaining lives, which then overrides the theoretical ones. So that way we manage it in the system.
Yep, I have got just a quick question before we go on to the next question from Steve, is that how long it takes to build the system, say, for example, for a medium-sized offshore platform, because the modular approach has to be built for a specific platform.
So, if you want to just implement such system, basically, so you can, it is ready to use, I would say. But if there is specific, because what we realize is every company has a different approaches to how they implement their RPI or their work processes. And if they want to implement their own work processes and RBI methodologies and those sort of things, then it could take 3 to 6 months, depending on the size of the changes to do. But such system should be ready to be deployed immediately as soon as somebody takes it. There are issues. One, there are implementation issues. The other thing is that data migration issues. You have a lot of data from past. You want to migrate it into the new system, and you want to recalculate and get the results which you have done it manually outside or in another system the same way in the new systems. So this takes a little bit time. So when I say implementation, things like changes in the risk metrics, the company has a risk metrics which is 6x6 or 5x5. They want to follow that. If it is a two people company or a 6 people company or 20 people company, the workflow will be different for managing anomaly, or how do the work packs are prepared, how the inspection reportings are happening. So all these things require certain configurations to adapt to the company requirement. What we don't believe is you put a system in place which is you try to fit a big company workflow into a small company, and that will not work. It will exhaust and people will not use the system. So what we are trying to explain it here is you should have a digital platform which helps configuring those things and fit for your needs.
Of course. Yeah, I just realized that we are about 5 minutes over. I know that you guys are, of course, very busy, and of course, especially Matthews, you are waiting for us for quite a bit of long time, and it has been actually quite late there. Would you be okay to stay for about 10 more minutes so that we can just go through a few more questions, or
Yeah.
would you like to report them at the end, probably through emails, or you good to go?
Yeah, sure.
Perfect. So the next question is from Steve, is that what is the upfront cost of setting up this system on man hours, and what is the continuing license fee on the annual basis?
I think I will keep it this question for a more one-to-one kind of scenario where
Detail, yeah.
you can write to us and we will answer that.
Perfect.
There are a lot of different factors we look at. We believe on the way the number of assets and the benefit the company gets. Based on that, it should be licensed. So we will work out and give you a correct costing. A company which is now having one plant versus having 10 plants. 10 plant, the license will be costlier to the one plant. So,
and the way to look at this is to say, well, we want to make sure that every company is able to afford using a digital enterprise system, really, and that's the whole point.
That sums it up greatly. The next one is from Steve Peterson again, is lastly, as a technical authority, how do I assure that the system is working independently? That is, how can I sample audit, how can I perform sampling of the audits for specific corrosion threats?
okay, so the system has got a lot of QA/QC related things built into the system. But on the same time, I believe this is a knowledge which comes over time while you are using it, and you may want to fine-tune the rules to audit it. So you can go in and you yourself can configure the rules to say that I want to see this data from this perspective and see whether it is working or not. Yeah. So that way, you are basically able to see that the system is working or not. Did I answer the question, or?
No, that sounds great. Just one more, or actually two more questions from Urvishwala, is that up to what accuracy the software can provide the output? Any size limitation for diameter for assessment, or is there any other?
It follows if we are using API 581, then the diameters which are there, it will work based on that. If we have to add something, we will be able to add it because this is fully configurable system. There are times which are not damage mechanisms which are not covered by 581, but the guidances are there in 571 or anything else. On the request of client, we just modify it to suit for the operations need.
That's great. Last question is from Stephanie Okie. Is that do you have the process within the enterprise system to manage correct, inaccurate legacy data, which is a very common problem, especially for North Sea?
Yeah, and I would say that this is where when we are doing a data migration, then we need to make sure the data coming into the GOOS system is classified properly, cleaned properly, and then uploaded into the system. There are times when in the past, when we have migrated the data, we saw that for example, wall thickness data over years are not showing a trend of going down, but it is going up because they have used wrong calibration in the data loggers or something, or readings were never checked. QA/QC was not done when uploading into the system. So while migrating, we realized that, and it was showing that the wall thickness is growing rather than reducing. So those checks we do, and then make sure that good data is coming to the this new system and not continue with the bad data. And we work with the operators to make sure they understand the problem, we come up with a solution together. On the same time, in the new system, after the data is uploaded into the system automatically does QAQC on those wall thickness readings or any other inspection data which is coming, and checks whether it is below the minimum required thickness or is it the previous information, and this information is aligned or not. Suppose you said there is a pitting in the last data and now there is no pitting. There was an internal corrosion reported last time, but no corrosion reported this time. So this kind of thing system automatically identifies and tells that, okay, you need to do something about this, go and do a re-inspection. We cannot accept this data straight away like this.
So there is a verification routines built into the system that allows you to ensure that the data that you've migrated is correct and valid, basically.
Yeah.
Cheers. Thank you very much. With that, I would like to thank you from Aberdeen's side. And just to remind you guys that we have got next month, 28th of 3rd, 2023, we have got another technical event, which is effective pipework analysis and inspection planning using digital twins. And with that, I would request all of you to please put your hands together and please join me to say thanks to Raza Amin for giving this very interesting presentation, and Matthews Warkey to join for the QA session, although it has been quite late where he is in Malaysia, and I have seen quite a few people joining us from Far East. For that, I'm thankful to all of you, and of course, please, I would like to say thank you very much, Raza. With that, I would like to close tonight's presentation, and thank you very much for joining.
Yeah, thank you, Ijaz, for organizing it, and thank you everybody for participating today. Really appreciate it, and we really appreciate everybody's participation and their time.
Cheers. Thank you very much, everyone. See you next month. Have a very good time.
All right.
Cheers. Bye.
All right. All the best. Bye-bye.